Hi, and welcome to Introduction to Cloud Computing. I am Harshada Tapale. Today, when we see that the discussion within the companies has shifted from should we move to the cloud to when are we moving to the cloud and how will we do it, it is important to know what is cloud and how it can help us address the challenges in today's business world. Therefore, in this module, we will see what are the challenges in the business, what is cloud computing and its components, the common terminologies associated with cloud computing, overview of virtualization, and cloud computing architecture. To begin with, let's first try to understand what today's business environment is like and what are the challenges faced by the companies. Today, if we move around in the business world, we see that the term VUCA is making waves in business world. This means that the business environment is volatile, uncertain, complex, and ambiguous. And in such an environment, companies are facing multiple challenges. These challenges can vary from something like operational excellence, reduced costs, unlimited capacity, rapid strategy, and sometimes even being environmental friendly can be a big challenge. However, when it comes to computing, we can meet all these challenges. Cloud computing is our answer to all these challenges. We can see that today cloud platforms are enabling new complex business models and orchestrating more globally based integration networks this year than any analyst or advisory firms had predicted. With the cloud, businesses no longer need to plan for or procure servers and other IT infrastructures weeks or months in advance. Instead, they can instantly spin hundreds and thousands of servers in minutes and deliver results faster. To know the importance of having the knowledge of cloud computing, let's look at some of the global trends first. So, the global cloud computing market today or now will be reaching approximately $1,250 billion by 2025. If we just consider Salesforce and its ecosystem, there would be about 1.9 million direct and 2.8 million indirect jobs that will be created. Also, we can see that 74% of tech CFOs believe that cloud computing has most measurable impact in their business this year. The enterprise cloud spending is also growing, and over 70% of enterprises has the opinion that cloud is no more optional for companies to be competitive, and it's kind of become very mandatory. And we can also see from the salary surveys result of this year that those working in cloud computing were commanding highest compensation. When this is the trend across the globe, let's also see what the future of cloud in India looks like. So, basically speaking, India is impacted by this trend in the most progressive way. With cloud rapidly altering the IT landscape and companies allocating huge share of their revenues for upcoming cloud innovations. If you want to look, for example, we can see that AWS has opened its infrastructure region in India in 2016, investing about $2 billion. At the same time, VMware has opened a new facility in Bangalore, investing about $500 million over a period of, say, 3 years. So, cloud vendors from across the globe are looking at India as a very large market to generalize it. And for a matter, even the Indian government has embarked on cloud computing initiatives, and national cloud services are availed by over 250 government departments and entities. So, in short, we can say that the scope for cloud computing and its successful application in Indian companies and institutes is about to go up. So now that we understand why cloud is important and what significance it has, let's first understand what this cloud is. So, cloud by definition would be an approach to computing that leverages the efficient pooling of on demand self service virtual infrastructure. So, what is this virtual infrastructure? If you look at the figure, you will see that it comprises of two layers. So, the one at the bottom is the physical layer, and on top of that is something called abstraction layer. And this physical layer, which is the hardware, comprises of compute, network, and storage. And abstraction layer will be the software layer. So just to summarize, we can say that virtual infrastructure is a collection of hardware and software that enables five essential characteristics of cloud computing, which we will see in upcoming slides. And it is conceptually the abstraction layer that sits above the physical layer. Now that we have seen what cloud is, it's very, very important to see what its components are. So, the first important component of cloud is client computer. So, clients are the device that the users use to interact with the client. There are three type of clients. There are three type of clients. First is mobile. It's basically the mobile devices like tablets, laptops, mobile phones. Then we have something called thick client. So thick client is basically a computer which has hard drive and moving parts and boots by itself. So we can say that it can be independent of servers. So it need not be, but it can be. And then you have something, and which is the most popular one, that's called thin client. So thin client is a simple network enabled computer without a hard disk or any moving parts. The next component that's very important is distributed servers. So often servers are in geographically different places, but these servers would act as if they are working next to each other. Then we have something called data center, and they look like this. So, data center is actually a collection of servers where application is placed and is accessed via internet. So, to say it is basically a large group of network computer servers, right? Then there is also something which is called a central server. So what it does is that it administers the systems such as monitoring traffic, then client demands to ensure everything runs smoothly. So it uses a special type of software which is called as middleware. And middleware allows computers to communicate with each other. So these are a few of the important components of cloud. And now we will see what the technology in itself is. So, if we want to say, have a definition for cloud computing, we have a definition from National Institute of Standards and Technology, which is a measurement standards laboratory and a non-regulatory agency of US government of commerce. And it defines cloud computing as a model for enabling ubiquitous, convenient, on demand network access to shared pool of configurable resources that are rapidly provisioned. So it is more of a technology and it's also a service. So this definition, which is provided by National Institute of Standards and Technology, is the most acknowledged and approved by many across the world. But if we need to have a simplistic definition for either someone who doesn't know cloud computing is, or even in general, then we can say that it's about providing IT services through internet. So that's the most simplistic definition. When we are talking about cloud computing, you would often come across certain terminologies which are closely associated with cloud computing. So let's just have a look at that. So the first and the most important, or the one which you hear quite often, is something called host. So host is basically a physical hardware with hypervisor. Then you have something called instance. So it's basically a virtual machine hosted on cloud providers' infrastructure. So we can say that instances use the internet to communicate with any machine, whether it's virtual or physical, and which is outside of its own network. Then this cluster. So cluster is a set of connected computers that work together so that it looks like they're in a single system. And if you want to simply speak about it, it's just a group of hosts. Then we have middleware. So as mentioned earlier, this is something which is used by central server, which lets the networked computers communicate with each other. Then we have load balancing. So load balancing is something which has to do with workloads. So workloads, as many of you must be knowing, are the amount of processing that the computer has been given to do at a given time. So workload can consist of some amount of application program running in the computer, and usually some number of users connected to and interacting with this computer's application. So what happens in load balancing is that when a computer or a set of computers is utilized more than the set percentage, additional computers are introduced and the extra workload is transferred to these new computers, thus maintaining the workload across the cluster. So it happens the other way around as well. So if the workload drops, the unrequired computers are immediately shut down and put into hibernation state. So this is how the workloads is managed across the clusters. Then we have scalability. So what's scalability? If in terms of example, we have to see, it's just, if you could imagine that you have to expand your IT infrastructure in the company, say from 80 to 100. That's scalability. So that's basically your ability to manage the changing demand. Then elasticity. It's simple, it's your ability to respond and adapt to the changes. Then a very important thing, which is multi-tenancy. So that's generally what you would come across, or that's the kind of architecture that would be used in many of applications, or many of the settings, infrastructure settings within an organization. So before we understand what multi-tenancy is, let's first understand what a tenant is. So a tenant is a group of users rather, who share a common access with specific privileges to the software instances. And in multi-tenancy environment, what happens is this multiple consumers or customers share the same application, which is running on the same operating system, on the same hardware, with the same data storage mechanism. And the distinction between the customers is achieved during the application design. So what happens is, thus, the customers do not share or see each other's data. So these basically, you can say, are very common terminologies associated with cloud computing that you would come across every now and then. And we should now understand what the characteristics, or for that matter, the essential characteristics of cloud are. So when we say cloud, it is mandatory for it to have all these characteristics. being on demand, providing on demand self service, broad network access, resource pooling, measured service, rapid elasticity, all these. So, first one, which we'll see, is this on demand self service. What this means is that consumers can unilaterally provision computing capabilities such as server time, network storage as needed automatically without requiring any human interaction with each service provider. The next characteristic is broad network access. What this means is that the capabilities are available over the network and can be accessed through standard mechanisms that promote use by heterogeneous thick or thin client platforms. That can be mobile phones, tablets, laptops, or for that matter, even workstations. The third one is resource pooling. So, what happens here is that providers' computing resources are pooled to serve multiple consumers using a multi tenant model, as we've seen, with different physical and virtual resources dynamically assigned and reassigned according to consumers' demand. So there is a sense of location independence in that the consumers generally have no control or knowledge over the exact location of the provided resources, but may be able to specify locations at a higher level of abstraction. Say, example, maybe they know about the country or the state or the data center. So these resources could include storage, processing, memory, and network bandwidth. The next characteristic is rapid elasticity. As we saw, elasticity is the ability to respond and adapt to changes. So, because of this characteristic, capability can be elastically provisioned and released, in some cases automatically, to scale rapidly outward and inward depending upon the demand. To the consumers, the capabilities available for provisioning often appears to be unlimited and can be appropriated in any quantity at any time. The last one is a very interesting one, which is measured service. When we talk about this characteristic, we can draw parallels with the utilities like electricity, telephone, water, which are metered. Cloud systems automatically control and optimize resource using or by leveraging a metering capability at some level of abstraction appropriate to the type of service. So, resource usage can be monitored, controlled, and reported, providing transparency for both the providers and consumers of the utilized service. Now that we know what cloud is, characteristics, what mm, common terminologies, and the technology by itself, let's see how we can utilize it. So to utilize it, there is something called as service models. So before we talk about what service models are, let's first understand what a service is. So we can say that a service is a logical representation of repeatable business activities that has a specified outcome. And these activities could be something like checking customer credits, providing weather data, consolidating drilling reports, so on and so forth. So, service in itself can be self contained. Sometimes it might be composed of other services as well. So basically speaking, we can call it like a black box basically, because you know what is input for it and the output for it, but you really might or might not know what the internal workings are like. So it might appear to be like a black box to the consumer. And when it comes to cloud services, we can say that it covers wide range of resources that a service provider delivers to the consumers via internet. So the first one or rather at the bottom of the pyramid is infrastructure as a service. So, infrastructure as a service provides storage, compute, and network resources as service, which can be used by developers and IT organizations to deliver business solutions. So, consumers can customize the entire infrastructure package by selecting, say, CPU hours, storage space, bandwidth, etc. So, it provides complete flexibility to consumers in choosing desktop, servers, network resources. And what it brings or how it adds value to the business is through business agility, cost reduction, reliability, scalability, privacy, and governance. So rather than buying these expensive servers and taking headache of setting up the data center, IaaS cloud helps business in reducing its capital and operational expenditure by quite a big proportion. So if we want to talk about a few of the examples, we have Azure from Microsoft, then we have Amazon Web Services, which is like the leader in this service, and we have IBM, VMware, so on and so forth. Quite a few actually. Next level up in the pyramid is platform as a service. So it's popularly known as PaaS. PaaS delivers development environment or operational environment as a service. It includes set of tools and services designed to make coding and deploying the application quickly and efficiently. The capability provided to the consumers is to deploy onto the cloud infrastructure consumer created or acquired application created using programming languages, libraries, services, and tools supported by the provider. So, this basically frees up the developers from infrastructure management, allowing them to focus strictly on development. So the prime examples could include Salesforce.com's Force.com. To let you know, Force.com was the first PaaS provider. Then we have Azure from Microsoft, App Engine from Google. So these are a few of the examples for PaaS. Topmost layer of the pyramid, which is the functional layer, is called Software as a Service or SaaS. The capability provided to the customer is to use the provider's application running on a cloud infrastructure. So the applications are accessible from various client devices through either a thin client interface such as a web browser or a program interface. Now, this type of cloud delivers a single application through the browser to multiple users. So basically, it uses multi tenant architecture. So the key benefits are that the consumers do not need to worry about the development and the management of these applications. The provider is completely responsible for all the updates and managing licenses, and most service management parameters like scalability, availability, maintenance, and service continuity. Consumer pays by means of subscription or pay-per-use model. So some of the typical solutions, the SaaS solutions we could see in the market are CRM, ERP, billing and invoicing, web hosting, online collaborations. And some of the examples of SaaS are your general webmails and Microsoft Office 365, so on and so forth. There are quite a few SaaS products available in the market now. So, generally, in case of a company's digital transformation, the first service that a company tends to be using is a SaaS, and then gradually it moves into infrastructure as a service. The other way of utilizing service models is deployment models. So, as mentioned in the earlier slide, deployment models are subcategories of IaaS. So, just to mention, deployment models are subcategories of IaaS. One of the way of deployment of infrastructure is private cloud. The cloud infrastructure in here is provisioned for exclusive use by a single organization comprising multiple consumers. Here you can create a cloud environment in your own data center and provide self-service access to compute resources to users in your organization. So it may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premises. The other way of deployment is public cloud. In here, the cloud infrastructure is provisioned for use by general public. It may be owned, again, managed, or operated by businesses, academic or government organizations, or some combination of them. What happens here is that it exists on the premises of the cloud provider. And the public cloud vendor is completely responsible for the hardware purchase and the maintenance and provides a wide variety of platform service that you can use. What happens here is that you can lease whatever hardware or software services you require on an as need basis, and thus you can convert your capital expenses for purchasing of hardware into an operational expense. It allows you to lease access to hardware and software resources that would be too expensive to purchase otherwise. So, although you are limited to hardware provided by the cloud vendor, you only have to pay for it when you use it. There is also a cloud infrastructure, which is composition of two distinct infrastructure, that's the public and the private cloud, which is called as hybrid cloud. So what it essentially means is using the combination of cloud services and on-premise systems. So this definitely, is the most common implementation approach for most companies. More than 47% of the companies these days are opting for a hybrid cloud setup. This hybrid cloud requires companies to ensure that their services are running efficiently but not independently. Yeah. So, if you want to give an example of hybrid cloud, you can say that you can host a high scale website in the public cloud and link it to a highly secure database in your private cloud or on premise data center. So that's hybrid cloud. There's another cloud deployment model which is often mentioned but is not, I can't say popular, but it's not used often, but has been mentioned, is called community cloud. So what happens within community cloud is that the infrastructure is shared between several organizations from a specific community with common concerns like security or compliance, jurisdiction, etc. Whether managed internally or by third party and are hosted internally or externally. Next, and a very important topic, which is virtualization. So, while understanding cloud, one of the important concepts to understand is virtualization, and that is because it powers cloud computing and helps deliver on its potential. So, we need to understand why we need to virtualize. We need to do so because it brings about cost saving, efficiency, speed, and also fewer physical components, which really makes it very important. Before we start to know about virtualization, we first need to understand that virtualization and cloud computing are not the same thing. So we can say that virtualization facilitates cloud computing, or in other words, cloud computing uses virtualization to give its benefits. So whether or not you are in cloud, you can still start by virtualizing your servers and then move to cloud computing for even more agility and increased self-service. So there is a distinction between virtualization and cloud computing. So we have seen what cloud computing is. Now let's see what virtualization is. So, virtualization is the process of basically creating virtual versions of physical components. So, this is a very simplistic, not really a definition, but a description, I can say. And it uses software to stimulate the existence of hardware and creates virtual computers. Okay, that's how it happens. And doing this will allow the businesses to run more than one virtual system and multiple operating systems and applications on a single server, as you can see in the figure. And this can provide economies of scale and greater efficiency. So, next is what is virtual computer? It's basically known as virtual machine. So let's see what it is. So, virtual machine, we can say, is the fundamental building block of virtual infrastructure and our software computers to be or consumers of the resources that are created and managed by the hypervisor. We'll definitely see what hypervisor is in next slide, but before that, let's understand this. So we can say that it is a tightly isolated software container, as you can see, which has operating systems and applications inside. So each self-contained VM is completely independent. Putting multiple VMs on a single computer will enable several operating systems and applications to run on just one physical server or the host. Yeah, and as we've seen earlier, host is a combination of physical hardware and hypervisor. So thin layer of software, which is called hypervisor, decouples the virtual machine from the host and dynamically allocates computer resources to each virtual machine as needed. So, the most important thing in virtualization or cloud computing is hypervisor. So, hypervisor, or we call it virtual machine monitor, is nothing but a computer software or a firmware or a hardware that creates and runs virtual machine. So a computer on which hypervisor runs one or more virtual machine is called as the host machine, and each virtual machine is called the guest machine. So a hypervisor would present the guest operating systems with a virtual operating platform and manages the execution of the guest operating system. So basically, there are two types of hypervisors. One is a bare metal hypervisor, and the other one is a hosted hypervisor. And to know more about hypervisor and the types of hypervisor, we have a separate video which will give you a fair idea of what hypervisors is. But we can't incorporate all this information due to the shortage of time. So this would probably give you a basic idea of what a hypervisor is. Then the next important thing is definitely cloud computing architecture. So cloud computing architecture refers to components and subcomponents required for cloud computing and the relationship between them. The various components of cloud architecture are on-premise resources, cloud resources, then software components and services, and middleware. The entire cloud architecture is aimed at providing the user with high bandwidth, allowing users to have uninterrupted access to data and application, on-demand agile network with possibility to move quickly and efficiently between servers or even between clouds, and more importantly, network security. To get a greater understanding of cloud computing architecture, we have separate videos which are available on our channel, so you can have a look at them and understand what are the different types of architecture and what are the different components and things like that. So now that we have seen most of the things like the technology, the components, the architecture, it's important to see what the benefits and what are the threats or what are the concerns vis-a-vis cloud computing. So the benefits are that we get shared resources, automation, reduced cost, increased mobility, agility, and scalability. But with all this, we still have some concerns, out of which security continues to be the top concern. And it can be seen, interestingly, that 50% of people feel that security is a barrier, and 50% think that provides benefits. And this will continue. And we will see that more and more people are tipping towards saying that security provides benefits. So that will happen gradually. Uh, and the security concerns will slowly diminish. However, with that, the privacy concerns are still rising. And we can see that at the moment it's on the third spot of cloud concerns. What that means is that the privacy policy and the privacy track record of the cloud providers or global cloud computing companies will be under greater scrutiny. So, this is something which is going to remain as a concern, but companies will try to address that with their privacy policies, I'm sure. You can refer these links to get more information on whatever we have discussed so far in this session, and that can give you a fair idea of some points that have not been covered in this session due to the lack of time. And thank you very much for watching this video. If you have any questions or comments, do post below the video, or else reach out to us on our social media pages or through our website, and continue with the next video to know more about cloud vendors and careers. Thank you so much.